The commercialization of sodium-ion batteries could happen much sooner if lithium battery prices continue to rise. The cost of lithium has climbed dramatically, increasing from $4,450 per ton in 2012 to $78,300 per ton in 2022. That's an incredible 1,654% increase over the last decade, including a 480% jump in just the previous year. Now imagine a battery that costs only around $15.15 per kilowatt-hour, compared with approximately $101 per kilowatt-hour for a lithium-based battery. This is exactly the exciting breakthrough that CATL is introducing. So, what makes this revolutionary battery so inexpensive? What other benefits does it offer? We'll answer those questions and much more in today's episode of Tesla Car World. Welcome back to the channel, everyone. Before we get started, don't forget to subscribe if you haven't already, and ring the notification bell so you never miss any of our upcoming videos. Now, let's jump into today's topic. Battery technology is advancing at an incredible pace, making it difficult to keep up with every new development. Even so, CATL has already established a large supply chain for sodium-ion batteries and has begun discussions with several automakers about adopting this technology. Sodium-ion batteries are affordable, safe, and ready for use. But can they truly challenge lithium-ion batteries? Elon Musk once commented that lithium prices had reached insane levels. So how does the cost of a sodium-ion battery compare? The biggest advantage of sodium-ion technology is its low cost. Sodium makes up about 2.3% of the Earth's crust, making it more than 1,000 times more abundant than lithium. Looking at the raw materials, lithium carbonate currently costs around $570,000 per ton, while sodium carbonate costs less than $3,000 per ton. That makes sodium carbonate roughly 190 times cheaper than lithium carbonate. CATL also states that sodium offers better electrical conductivity. Because of this, the electrolyte concentration can be reduced, lowering battery production costs by approximately 85%. In addition, sodium is far more common, easier to obtain, and much less expensive than lithium. For comparison, the average cost of a Tesla 4680 battery pack in 2022 was about $101 per kilowatt-hour. Using that figure, the estimated cost of a sodium-ion battery comes to roughly $15.15 per kilowatt-hour, nearly 7 times cheaper than the 4680 battery. That means if you own a Tesla Model 3 standard range with an estimated 50 kWh battery pack, instead of paying around $5,050 for the battery, the overall battery cost could be dramatically reduced. A revolutionary battery at such a low price sounds impressive, but how much driving range can a sodium-ion battery actually provide? Its performance in passenger vehicles shows that sodium-ion batteries can generally meet the requirements of cars with a driving range of up to 248 miles ***. Through its innovative ***AB battery system integration technology ***, CATL has successfully combined sodium-ion and lithium-ion cells, allowing each chemistry to complement the other. This hybrid approach increases the overall energy density of the battery pack. As a result, sodium-ion battery systems can support electric vehicles with a range of up to ***310 miles ***, compared with the *279-mile *** range of the Tesla Model Y, equipped with 4680 battery cells. Of course, charging speed is another major factor for EV owners. So how quickly can a sodium-ion battery recharge? According to CATL, its sodium-ion battery cells can charge from *0% to 80% in just 15 minutes at room temperature. For comparison, a Tesla Model Y using a public fast charger typically takes about *32 minutes to recharge from *0% to 80%, meaning the sodium-ion battery can reach the same level in less than half the time. Another important question is how well sodium-ion batteries perform in extremely cold weather. Lithium-ion batteries operate most efficiently between **15 degrees C and 35 degrees C**, which is why cold winter conditions often reduce their performance. CATL says its sodium-ion battery can retain around *90% of its capacity at -20 degrees C**, and even at -40 degrees C**, it still maintains more than 70% of its capacity. This means the reduced driving range that many EV owners experience during winter could become far less of an issue. At the same time, there is currently no evidence suggesting that sodium-ion batteries experience significant performance degradation at higher temperatures either. So, just how safe are sodium-ion batteries? Like lithium-ion batteries, sodium-ion batteries work by moving ions back and forth between the cathode and the anode. However, sodium ions are larger than lithium ions, which creates greater demands on structural stability and electrochemical performance. This has been one of the main challenges slowing the large-scale commercialization of sodium-ion technology. Even so, sodium-ion batteries offer a safety advantage because they are less flammable than conventional lithium-ion batteries. The latest sodium-ion technology uses a naturally self-extinguishing electrolyte that is highly resistant to temperature changes and remains stable even while operating at high voltages. A key factor behind this improved safety is the ultra-thin protective layer that forms on the anode. Once this layer is created, it remains stable throughout the battery's life, contributing to the long cycle life reported in recent research. Although lithium metal battery technology has achieved major advancements over the years, its chemical composition continues to present several significant engineering challenges. One of the biggest drawbacks of sodium-ion batteries is their lower energy density compared with lithium-ion batteries. This means that an electric vehicle using a sodium-ion battery of the same physical size as a lithium-ion pack would generally travel a shorter distance on a single charge. CATL's first-generation sodium-ion battery delivers an energy density of around *160 Wh/kg*. The company introduced its first sodium-ion battery prototype last year and has since been working on second-generation technology capable of reaching *200 Wh/kg*. By comparison, today's mainstream lithium-ion batteries typically offer energy densities between *200 and 300 Wh/kg*. Although sodium-ion batteries still have lower energy density, the technology continues to improve rapidly. In fact, the first generation of sodium-ion batteries already performs better than lithium-ion cells produced 6 or 7 years ago. When it comes to real-world applications, battery performance ultimately depends on the intended use. The first generation of sodium-ion batteries is well suited for a wide range of transportation electrification applications, especially in regions with extremely cold climates where their advantages become even more apparent. They can also be adapted for virtually every type of energy storage application. Today, many promising battery technologies are being developed in research laboratories, but most require *5 to 10 years before reaching commercial production. However, sodium-ion batteries appear to be progressing much faster. Major battery manufacturers, particularly CATL in China, have already announced plans to begin mass production in *2023 *. In the long run, sodium-ion batteries could become the mainstream choice for many everyday electric vehicles, while lithium-ion batteries are likely to remain the preferred option for premium, long-range models. For most daily driving needs, the higher cost of lithium may no longer be necessary. This breakthrough could be just as transformative as the arrival of the electric vehicle itself, providing a battery technology that is both more affordable and practical. So, when do you think we'll start seeing sodium-ion batteries become common on the market? That's something worth thinking about. Thanks so much for watching and supporting our channel. If you enjoyed today's video, be sure to leave a like, share it with others, subscribe to the channel, and turn on notifications so you never miss the latest updates in the world of electric vehicles and green technology. Until next time, take care and stay safe.